PrivateLink is a game changer for organizations that need secure private connectivity between their VPCs and AWS services or other VPCs. Think of it as a private highway within AWS network backbone. Throughput Throughout this presentation, we will explore real-world scenarios, dive deep into configuration examples, and I'll share best practices I've learned from implementing PrivateLink in production environment. We'll start with the fundamentals and build up to advanced like cross-account databases, access, and SaaS integration patterns. Let me start by explaining what PrivateLink actually is and why it's so important for modern cloud architectures. AWS PrivateLink enables you to access AWS services and VPC endpoint services privately without your traffic ever leaving the AWS network. This is crucial for security-sensitive workloads. Imagine you have an application that needs to access S3 or RDS, relational database. Normally, this traffic would go through an internet gateway or NAT gateway, exposing it to the public internet. With PrivateLink, that same traffic stays completely within AWS private network. The 4 key benefits shown here are transformative, enhanced security, eliminating internet-based threats, improved performance and reduced latency, simplified architecture, removes complex routing, and cost optimization can significantly reduce your AWS bill. I've seen organizations reduce their data transfer cost by 60% and improve application response time by 40 milliseconds just by implementing PrivateLink. Now let's dive into how PrivateLink actually works. Under the hood, this architecture diagram shows the complete flow of how your applications connect to the service privately. On the top, we see the customer VPC, consumer VPC. This is where your application live. Your EC2 instances and Lambda functions connect to a VPC endpoint, which act as the gateway. The magic happens in the middle with the PrivateLink connection. This is AWS private network infrastructure that routes your traffic without it ever touching the public internet. On the provider side, we have network load balancers that distributes traffic to your target services. For AWS services like S3 and DynamoDB, this is all managed by AWS. What's really powerful is that this same architecture works whether you're connecting to AWS service or custom services hosted by another AWS account, like a service from a SaaS provider. There are 2 types of VPC endpoints, and understanding when to use each is crucial for both cost and performance optimization. Gateway endpoints are only available for S3 and DynamoDB. They are completely free, no hourly charges at all. They work by adding routes to your route table. I always recommend these for S3 and DynamoDB access when possible. Interface endpoints are for everything else: EC2, APIs, Lambda, RDS, and hundreds of other AWS services. These create network interfaces in your subnet and do have hourly charges, typically around $7 to $10 per month per endpoint. The key difference in implementation is that gateway endpoints modify your routing tables, while interface endpoints create actual network interfaces with private IP addresses that your application connects. So one is doing route table injection for AWS services like S3 and DynamoDB, and the other one is basically a link on your network. Let me share some real-world scenarios here where PrivateLink provides tremendous value. These are patterns I've implemented multiple times in production environment. Multi-account architecture is probably the most common use case I see. Large organizations often separate their environments, dev, staging, and prod in different accounts. PrivateLinks allows secure communication between these accounts without VPC peering complexity. SaaS integration is growing rapidly, If you're a SaaS provider offering private link endpoints to your enterprise customers can be significantly differentiator and often commands premium pricing. Data analytics pipelines are perfect for private link because they typically process sensitive data that should never touch the internet. I've worked with financial services companies where this is a regulatory requirement. Hybrid cloud connectivity combines private link with direct connect to expand on-premises network to AWS services privately. This is very powerful for migration phase of moving to AWS. This is one of my favorite private link patterns because it solve a real security challenge. Here we have a production database. We have a production database in a separate AWS account from the application account. The application account contains web servers, web servers that need to access database, but we want complete network isolation between accounts. Traditional solution like VPC peering created broad network access. With private link, we create a very specific controlled connection. The database account exposes only the database service to a network load balancer and private link endpoint. The application account creates a VPC endpoint and endpoint that connects to the service. The beauty is that only database traffic can flow between accounts. No other network is as possible. This is a key differentiator. Security benefits. Database traffic never leaves AWS backbone. Fine-grained IAM controls with cross-account roles. Network isolation between accounts. Audit trail for all database connections. That's all benefits you get from this. This diagram shows how a SaaS provider can offer private API access to enterprise customer. This is becoming increasingly important as endpoint. What's powerful here is that the SaaS provider can offer both API gateway integration for REST APIs and direct service access for custom protocols or maximum performance. The monitoring and security components here ensures customer benefits, eliminate data egress charges, and then 20-30% improved API response time, meets compliance requirement. Provider benefits, premium pricing, 15 to 20% uplift. Service differentiation, enterprise customer requirements, reduced support burden. Let's get the hands-on and create your first VPC endpoint. I'll start with a gateway endpoint for S3 because it's free and demonstrate the core concept clearly. The AWS CLI command shown here creates a gateway endpoint for S3. It's tied to the VPC ID, your VPC ID. This is the service name for S3, and this is the endpoint type is gateway. Routing table IDs is where the routing table is going to terminate that VPC endpoints. What happens behind the scene is that AWS adds routes to your specified route tables, pointing S3 traffic to the endpoints directly. You can see these routes if you check your route tables after creation. The service name format is always com.amazon.com, Amazon AWS US West -2. It's this is one important note: gateway endpoints only work within the same region. If you need cross-region access, you will need a different solution. After creating these endpoints, any S3 API calls from instances and subnets associated with this route table will be able to automatically use the private endpoint because the traffic is going directly using the route tables. Interface endpoints are more complex but much more flexible. This example shows creating an endpoint for the EC2 API, which is commonly needed for applications that need to manage EC2 instances. Key differentiator from the gateway endpoints, we specify the subnet ID the subnet IDs where the network interfaces are going to go. This is where the network interfaces will be created. Security groups is the security group that you want to attach to those instance IDs. This way you can restrict what goes to that instance ID using security groups. The subnet selection is important. High availability. I recommend using subnets in multiple availability zones. This way you don't have a single point of failure. Security groups control which traffic can reach the endpoint. You'll need to allow HTTPS port 443 from your application subnet. Private DNS enabled is crucial. It allows your applications to use standard AWS service DNS names like ec2.amazonaws.com and have them resolved to the private endpoint. The policy document control which API actions are allowed through the endpoint. This provides fine-grained control. Example of the example endpoint policies are one of the most powerful but underutilized features of PrivateLink. They act as a firewall for your endpoint, controlling exactly which actions are allowed. This example policy allows only 3 specific EC2 actions: describe instances, describe images, and describe snapshots. Any other EC2 API calls through this endpoint would be denied. The condition is based on your condition ensures that only resources within your specific VPC can use the endpoint. So that's restricted. I often see organizations skip endpoint policy, but they're incredibly valuable for compliance and security. You can restrict access by time of day, source IP, IAM user, or any combination of conditions. In financial services, I've implemented policies that only allow read operations during business hours and require special IAM rules for any website operation, any route operation. Remember, endpoint policies work in conjunction with IAM policy. Both must allow an action for it to succeed. So this is an example of the security group that you can specify. As EC2 security group, you create a security group for the VPC endpoint, and then you basically attach it to your VPC. And then on the security group ingress, allow ingress for that endpoint using the source group. Allow it port 443 and sources from 10.0.0/8. And the port 443 required for all AWS service communication, and source CIDR is or specific subnet to allow. Outbound rules. Responses automatically allow stateful because the incoming request is going to come through that VPC endpoint. It's going to get back out without a specific security rule. Database endpoints example here, we create an EC2 authorize another rule for that group. We can assign to allow port 5432 for database applications. Private DNS is where the magic really happens. It's what makes PrivateLink completely transparent to your applications. No code changes required. When private DNS is enabled, AWS automatically creates private hosted zones in Route 53 for the AWS service domain. These zones contain A records pointing to your endpoint's private IP address. The DNS resolution flow is fascinating. Your application tries to resolve s3.amazon.aws.com. The VPC DNS resolver checks the private hosted zones first, finds a match, and returns the private IP instead of public IP. This means your existing code using AWS SDKs continues to work unchanged. The SDK makes calls for s3.amazon.aws.com, but they automatically routed through your private link. For troubleshooting, you can verify private DNS is working by running NSLOOKUP and running that DNS checks. The command here to enable DNS support, we talked about it earlier, but this is the command that allows you to get those information routes directly through that private link, our VPC endpoints. Now let's explore how to create your own endpoint services. This is powerful for sharing services across accounts or offering private API access to customers. The process starts with a network load balancer. This is a requirement. This requirement for VPC endpoint services can only be created with the network load balancer, not application load balancer or classic load balancers, just network load balancer. The network load balancer must be internal. The scheme is internal, meaning it's only accessible within AWS network, not from the internet. You'll target your backend services through this network load balancer. Creating the endpoint service is straightforward. You reference the network load balancer here by its ARN, and then acceptance, you reference ARN and decide whether to require manual acceptance of endpoint connections. I usually recommend requiring acceptance for production services because it gives you control over who can connect and provide an audit trail as well. The service gets assigned a service name, so that service name will basically be something like this, and this is what customer use to create endpoints. Cross-account access setup. Setting up cross-account access requires coordination between the service provider and consumer accounts. Let me walk through both sides of this process here. The provider account first grants permissions to specific AWS accounts. So here we are relying on creating an EC2 VPC endpoint service permissions. We're gonna basically specify the service ID that you have, and then add allowed principal to add the AWS account using the modify VPC endpoint service. You can specify individual accounts, or you use wildcard through, though I don't recommend wildcard for production. The consumer account, using the service name that you have, the service name that you provide them, then creates a VPC endpoint. This is creating a VPC endpoint, and then they're gonna point it to the actual service name that you provide them. This service name is unique and acts like a private API endpoint. If acceptance is required, the provider must accept that connection here, so that this approval process is important for security. And then accepting the connection can be done via CLI using this command EC2 accept VPC endpoint, and then service ID, and accepting that connection. For customer endpoint service, you will often want to provide branded DNS names instead of the AWS generated endpoint URLs. This improves the user experience significantly. The process involves creating a private hosted zone in Route 53 for your custom domain. This zone is associated with the consumer VPC. The A record or alias record points your custom domain to the VPC endpoint DNS name. This allows consumer to connect using the API myservice.internal domain using that VPC. So it's going to be, the DNS name will be API myservice.internal. So that's basically what you are adding here. So you can implement advanced DNS patterns too, like weighted routing for A/B testing, or failover routing for high availability across multiple regions. Monitoring private link is crucial for maintaining reliability and troubleshooting issues. AWS provides several monitoring tools that I use regularly. VPC flow logs are essential for understanding traffic patterns and troubleshooting connectivity issues. I always enable them for VPCs with PrivateLink endpoints. CloudWatch, so here we enable VPC flow logs, EC2 create flow logs, resource type VPC, specify the VPC ID, and then log destination will be CloudWatch logs. CloudWatch metrics provide real-time visibility into endpoint performance. Key metrics include client error count, packet drop count, connection count. So for custom endpoint services, you can also monitor the network load balancer metrics to understand traffic distribution and backend health. Setting up CloudWatch alarms for setting up an alarm for high error rate or connection failures can help you detect and resolve issues before they impact the user. DNS query logging can also be valuable for troubleshooting. Here there's some commands that check endpoint. You can check the endpoint with this command, describe endpoint, and then here you can do NSLOOKUP and see the IP address, and test connectivity using curl command. Understanding PrivateLink cost is important for budgeting and optimization. Let me break down the cost structure and share optimization strategies. Gateway endpoints for S3 and DynamoDB are completely free. You only pay the data processing fees, which are typically much lower than NAT gateway charges. Interface endpoints have an hourly charge that costs around $7.20 to $10 per month, depending on region, plus data processing cost of 1 cent per gigabyte. For high traffic scenarios, these data processing fees are often much lower than NAT gateway costs, especially for cross-AZ traffic. Custom endpoint services require load balancer, which add their own hourly and data processing costs. For cost optimization, consider sharing endpoints across multiple subnets and using gateway endpoints whenever you can. The most common PrivateLink issues is how to resolve them. These troubleshooting steps will save you hours of debugging. DNS resolution are the most frequent issue. Always verify that DNS support and DNS host names are enabled on your DNS supports and DNS host names are enabled on your VPC. Enable DNS support, enable DNS host names. Security groups misconfiguration can cause connectivity failures. Remember that endpoints need inbound access on port 443 for AWS services, and your application need outbound access to the endpoint. Route table issues with gateway endpoints can prevent traffic from reaching the endpoint. Check that your route table includes the endpoint routes. Endpoint policies that are too restrictive can block legitimate traffic. Start with permissive policies and narrow them down gradually. For custom services, network load balancer health check failure are common. Ensure your backend services respond correctly to health checks on the configure port. Let me summarize the key best practice I've learned from implementing PrivateLink in production environment across many organizations. For security, always use the principle of least privilege with endpoint policies. Start restrictive and add permissions as needed. Enable VPC flow logs for audit trails. For cost optimization, use gateway endpoints for S3 and DynamoDB whenever is possible. Consider regional proximity and traffic patterns when designing your endpoint strategy. For performance, deploy interface endpoints across multiple availability zones for high availability. Use appropriate DNS TTL values and implement connection pooling in your applications. For operational excellence, implement comprehensive monitoring, automate endpoint creation with infrastructure as code, and document your endpoint architecture clearly. These practices will help you build reliable, secure, and cost-effective private link implementation that scale with your organization. So thank you for sticking around. PrivateLink is a powerful service that can significantly improve your security posture, reduce costs, and simplify your network architecture when implemented correctly. The key takeaway here are: start with gateway endpoint for S3 and DynamoDB, use interface endpoints for other AWS services, and consider custom endpoint services for cross-account or SaaS scenarios. Remember to monitor your implementation, use endpoint policies for security, and always consider the cost implications of your design decision. I encourage you to start with a simple S3 gateway endpoint in a development environment and gradually build complexity as you become more comfortable with these services. PrivateLink is one of these AWS services that becomes more valuable the more you use it, and I'm confident it will become an essential part of your AWS architecture. Thank you very much.